So this related rate problem says that the kite a girl is flying is 100 meters above ground. If it is being blown horizontally at a rate of 15 meters per second, how fast is the string being paid out when it is 125 meters away from her? Okay, so let's take a look here. What do we know? What is this telling us here? Okay. So here's the situation. So here's the girl right here. Okay. The kite is 100 meters above the ground here. Now, we're assuming it's being blown horizontally, so its height isn't changing. So that's going to be constant here. So normally I would put a y here, but I don't really need that because it's not going to be a variable here. That's actually going to be a constant. Now, I'm asking about how the string is being paid out, and here's the string going up to the kite. Here's the kite, right? Flying up here. The kite is moving this way. So I'm going to be giving it string. That's going to be along the hypotenuse of that triangle. Okay. So I know that the kite is 100 meters above ground. I know that's being blown horizontally at a rate of 15 meters per second. That's got to be this distance right here, x. Okay, x is my horizontal distance. So dx by dt is going to be 15 meters per second. Now, I also know that we're interested in how fast the string is being paid out, so I want to know what dz by dt is at the instant that the kite is 125 meters away from her. Now that's not horizontally away from her, that means directly to the kite. How far away is that? So and we're told here that's 125. Okay, so this is how much we know here. Now, what equation are we going to use that relates these parts of the triangle? And I think it's probably pretty clear that we're looking at, once again, the Pythagorean theorem. But in this case, I have a constant. I know that the height of the kite is going to stay the same all the time, so I can plug that in immediately. I'll take my derivative implicitly, because I got to take the derivative with respect to time. The derivative of 100 squared, you notice I didn't even evaluate 100 squared because its derivative is just going to disappear. It's going to be 0. Then we get 2z dz by dt. Good. Now I am looking for dz by dt. So I'm going to get that by itself here, but first I'm going to cancel out those 2's. And I will bring dz by dt over to the left-hand side because I know a lot of you are going to want that over on the left-hand side. That's not a problem. And so this will become x over z dx by dt. Okay. Now, I know at this particular instant that I'm interested in that 125 meters of string is being paid out. I know that dx by dt is going to be 15. What I don't know is horizontally at this instant how far away that kite is. So I got to go back to the Pythagorean theorem. I got to figure out what x is. Oops, sorry. I'm going to add 100 squared, and this is going to be 125 squared. Okay? So now x squared is going to equal 125 squared minus 100 squared. So let's figure that out. 125 squared minus 100 squared. And I'm going to get 5,625. And again, said it before, said again, I am hoping beyond hope that works out to be a nice number. Square root of 5,625. Ooh, and it does. So the square root is going to be 75, and I know that it has to be positive 75 because of the scenario we're describing. Okay, so now I can take that value and plug that into here. Actually, this becomes fairly easy to calculate here. This will be 75 times 15 divided by 125. And the answer is 9 meters per second when I multiply that all through. Because now remember here that this is in meters per second and I'm dividing, so it's meters divided by meters times meters per second. All those units are going to cancel out to get you that. 9 meters per second. Actually, it worked out really nicely.